Hello, I'm Gary Rubenstein. This is part 8 in a series of I don't know how many videos that will take you from kindergarten through about 11th grade math. I'm still in elementary school on part 8. Just wanted to mention that there are some things that kids can think about and do some mathematical thinking about geometry. Very young children, I'm talking like 3, 4 years old, will have jigsaw, will have these like puzzles that have like wooden pieces that fit in, and they learn the basic shapes of rectangle, square, triangle, and circle. Sometimes there's other pieces. My daughter had one. It had like a pentagon and a hexagon. But let's just say these are the four most important shapes in math. And I guess an interesting, just like mathematical thing to think about is, is a square a rectangle? I like that question because you might say no. A square has equal sides, and a rectangle has unequal sides. Mathematically speaking, a square actually is a rectangle because a rectangle, the main thing about the rectangle is it has these nice square corners, and so does the square. So a square is a special type of rectangle. Anyway, it doesn't matter if they know that. That's just an interesting thing to think about. You could draw a picture and say true or false. This is a rectangle, and they would say true. And then if you get it down so that the sides, you can kind of make it more and more square-like, and they're still saying true. But then when you make it actually a square, they might not, be sure, is it a rectangle? Anyway, that's just like a mathematical thing, like all squares are rectangles, but all rectangles are not squares, sort of a logical thing. The concept of angle is actually a kind of sophisticated concept. The word triangle means it has 3 angles. An angle is one of these sort of L-shaped things. I guess this is one way to think about it. Anytime you have 2 lines that share an endpoint, you have, an angle. And depending on sort of how wide apart the 2 sides are, your angle can be bigger or smaller. When an angle makes a perfect L-shaped thing, we call that a right angle. When an angle looks more like a V, it's called an acute angle. And when an angle looks like sort of a stretched out V like that, it's called an obtuse angle. So a triangle has 1, 2, 3 angles, whereas a rectangle has 4, and for the rectangle, all 4 are right angles. I don't think they need to know much more about angles than that. Yes, angles are measured in degrees, and the right angle is 90 degrees, and obtuse is more than 90, acute is less. I think these 3 words are just good vocabulary words that kids can add to the 4 words that they learn as small children: rectangle, square, triangle, circle. I think having, the word angle and acute, obtuse, and right are good. When you have lines, if 2 lines intersect, cross each other, so that they make right angles, we call those lines perpendicular. And when 2 lines are going in the exact same direction, so they don't actually get to cross each other no matter how long we make them, And these words, the reason I mention is that those are words that are used in real life, parallel. You talk about a street. I live in New York City, so we can talk about, 100th Street is parallel to 101st Street, but it's perpendicular to Amsterdam Avenue. I think the words perpendicular and parallel are some good words to add to the vocabulary of a kid by the time they're, in elementary school. I'm not going to commit myself to a grade. Two important concepts in math are perimeter and area. So perimeter is if you were walking around a thing. So this is 10, 2, 10, 2. So here's a rectangle, and the perimeter is 22. Because if it's 24, these don't get made with editing. And now my pencil's not working. There it is. I do one take, so it's not 22 though, but it is 24. So that's the perimeter. You could have another rectangle that's less sort of skinny, taller. Maybe it's 9, 9, 3, and 3. That perimeter of that rectangle is also 24. So two rectangles could have the same perimeter, but sort of be like a different shape to them. What area means, I'll take those same two rectangles. So that first one was 10 and 2. Area is how many little boxes would it take to cover the shape. This isn't drawn that nicely to scale. 10 by 2 should look something like that. And this should be 5 times 1 and 2. That's a better 10 by 2. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 by 2 rectangle, and its area is 20, which means 20 of these little 1 by 1 squares would cover the rectangle perfectly. And we can get the area by just adding together. Sorry, by multiplying together. Again, I do one take. For all you know, this is the 5th time I've tried to record this video. We say that area is length times width. Some people say it's base times height. This is probably the length, and this is probably the width. Maybe not, though. I don't know. To me, could very well be argued that that's the width. It's an unresolved question in math, I think, which is the length and which is the width. But either way, it doesn't matter because you multiply the two numbers together. And this idea is also is good when kids are learning multiplication. They can see that it's like 10 plus 10. There's sort of 2 rows of 10, 10 plus 10, which is 2 times 10. So you can introduce area at the same time that you're introducing multiplication. Perimeter is length plus, depending on what order I add these in, I could say length plus length, length plus width plus length plus width if I was kind of going around it this way. Or I could just say 2 times length plus 2 times width. There's other shapes. So for a square, that's not much of a square. For a square, let's say it's 6 by 6 by 6 by 6. The perimeter is 6 plus 6 plus 6 plus 6, which is 24. We could say that it's 4 times whatever the side length is. And the area, in this case, is 6 times 6, which is 36. So the area is side times side. There's a special formula just for square, because a square just has a side, whereas a rectangle has length times width. Funny thing about rectangles, if I take my 2 by 10 rectangle that has perimeter 22, and I take my 9 by 3 rectangle, which has perimeter 22, an interesting question is, must these two rectangles have the same area? And the answer is no. In this case, it's 20. In this case, it's 27. So that's kind of puzzling. I like to ask questions like that so that sort of trick students into thinking, oh, yes, same perimeter must have the same area, and then show them that it's not. I feel like surprising, sort of tricking them, and then showing them, I feel like you remember something you get tricked by. That's what I think. Rather than just tell them, hey, here's a fact. You know, you ask them a question. Do you think they have the same area? And if they say yes, and you say, actually, they don't, it might stick into their minds more. That's not based on any theory of neurology that I know, just something that I've noticed. Or in my own learning things, like learning chess and learning different things, I remember things that I get like traps, tricks I fall for. Next shape is the triangle. So if I have a triangle, let me draw a triangle like this. Well, the perimeter of a triangle is easy. You just add together the 3 sides. But area of a triangle is not so obvious. If you try to imagine like little squares covering it up, you know, it's kind of confusing because some of the squares, if you try to put squares over it, you know, they don't fit perfectly like they do with a rectangle or with a square. So for a triangle, we need something a little more sophisticated. Well, there's several types of triangles. The easiest type of triangle to understand the area of is the so-called right triangle. So if you see this little square in the middle. The trick to the right triangle is if you put a second one upside down, together they would make a rectangle. And that rectangle's area would be 3 times 4. The 5 doesn't even get used in the area. But it's not, that's double, because the rectangle is only half of this, so you divide it by 2, and the area is 6. And that would be hard to picture by like stacking squares, because like I said, you'd have to cut the squares up to make them fit. But for a right triangle at least, the area is, you know, base times height divided by 2. And for a right triangle, the base and height are the 2 perpendicular sides, and that 5 doesn't even get used in the area. Now, if a triangle is not a right triangle, let's say 10, 5, 8, something like that. Well, that one's not so obvious. It's not a right triangle. What I can do is I can draw a rectangle that fits perfectly around the triangle. And if I draw this line down the middle, I have sort of 4 things here. A blue triangle, a green triangle, another green triangle, I drew this line straight down so that it split this triangle into two, the original one. Each of those are right triangles. So if I can figure out what the area of this big rectangle is, half of that's going to be the area of the triangle. Because the rectangle is made up out of 2 greens and 2 blues, and the triangle just has 1 green and 1 blue. But I have sort of a problem here. I know the base, the width, or the length, whatever you want to call it, of the rectangle, but I don't know the width or the height of the triangle. So actually, this question, 10, 5, 8, at least for elementary school, there's not enough information to find the area. We'd need to know this line here, which is called the height. So the 10 is the base, but the height is that. And we have to be told it. And I'm going to tell you that it's 4. Just telling you it. So the area, the 4 would be this also. So the area would be 10 times 4 divided by 2, which is 20. So the area of a triangle is base times height divided by 2. And this is the base. And the other 2 sides are, neither of them are the height. The height is that side. So you can trick students by telling them the other 2 sides, but that's actually not, for them, going to be enough information. In that right triangle, we didn't need it, because in a right triangle, the base and height are the 2 sides. They're perpendicular. But in a triangle that's not a right triangle, the height's not going to be one of the sides. It's going to be perpendicular to the base. So that's some interest. I really like this justification that the area of a triangle is base times height over 2, where the height is actually not usually one of the sides. I'm going to finish out the lesson on geometry. And like I said, geometry can be used, introduced, because they learn the basic shapes as like 3 or 4-year-olds. I mean, in preschool, they practice, the shapes. And they learn other shapes also. I've seen puzzles that have what they call an oval, which is also an ellipse. I've seen pentagon. I've seen hexagon. I've seen octagon, stop sign. I've seen puzzles with all these shapes in them. They're not bad. That you can count the pentagon, count the corners, 1, 2, 3, 4, 5, or count the sides, 1, 2, 3, 4, 5. Those are always the same. In a hexagon, count the corners. They're called vertices when you get older. Or the sides, there's 6 of them. Knowing the names of the shapes is good. I'm going to finish up today with circles. Now a circle doesn't really have sides, it's all curved. But the circle does have a line that goes through the middle, which is called the diameter. And let's just say that this circle has a diameter of 10. So a really difficult question is, what's the perimeter and area of the circle? Here's a square with side length of 10. And I can fit the circle inside of it. Square is bigger than the circle, so for the square, the perimeter is 40 and the area is 100. So the perimeter of the circle, otherwise known as circumference, which is a fancy word for perimeter, it's going to be less than 40, but how much less than 40? And the area is going to be less than 100, but how much less than 100? Now for a square, the perimeter is 4 times the side. the perimeter of the circle is related to the diameter. So here's the diameter 10. If you took this diameter and it was like a string, let's say, and you put it here and kind of laid it out, it would cover about that much. Then if I took a second diameter and laid that out, it would cover about that much. And then if I took a third diameter and laid it out, it would cover about that much. So it's a little more than 3 diameters. So the circumference is not 30. It's 30 something. It's close to 30. The big mathematical question is, what is that little piece? Right? If each of these guys are 10, how big is the leftover little piece? Well, it turns out it's about 1.4. And the circumference turns out to be about 31.4. Well, how could I have known that? So there are 3 diameters plus a little bit. By the way, that 1/4 is also about 1/7 of 10, or 14% of 10. So there was a diameter, a diameter, a diameter, and about 14% of a diameter, which is about 1/7. So I'm going to take away the 10s for now, just call D, D, D. And this tiny piece here is about 0.14 D. So it's about 15, it's about 1/7. So when you put those 3 Ds plus the 0.14 D, you get 3.14 times diameter. Well, that 3.14 is one of the most famous things in math, pi. Pi is simply how many diameters it takes. Remember that commercial? How many licks does it take to get to the center of a Tootsie Pop? How many, and it was actually 3, if you remember the commercial with the owl. How many diameters does it take to go around the circle? Well, the answer is 3 and a little bit, 3.14, and we call that number pi. So now you know, if you didn't know, pi is how many diameters fit around a circle. So the circumference is pi times diameter, which in this case is 3.14 approximately times 10, which is 31.4. Now I'm not going to tell you why, but you may not be surprised to find out that this area, which is a little less than 100, maybe a lot less than 100, there's a formula for that also, and it also involves this pi. It's pi times radius times, I'm going to write radius times pi, and here I'm going to write d times pi. So the radius is half the diameter, which is 5 in this case. And if you take 5 times 3.14, you'll get, a little bigger than 75. Maybe you get about 76, maybe 77. And that's what the area is. So you get 2 of the most famous formulas in math. Circumference of a circle is diameter times pi, and area of your circle is radius times radius, and then that answer times pi. But that's all pi means. Pi is how many diameters does it take to go around a circle. No matter how big the circle is or how small the circle is, it's always 1, 2, 3, and that little bit ends up being about 1/7 of the diameter, which is 0.14, and that's where the 3.14 comes from. Okay, so there's stuff about geometry. I think if 6th grader or something knows all this about geometry, they're in pretty good shape. Okay, hope you like that video.